Okay, this is going to take us about, I'd say about 20 minutes today. And you guys are a super smart, super fast class, so it should probably only take us like 17 because you're that amazing. And what we're going to do is we are going to pick up with our transformations. I don't know why the screen does that, but we left off with this piece. And now what we're going to do is we're going to apply transformations to 4 points on a function. And this is something that you will see on your test. So we want to make sure we know it well. Again, I don't know why it's doing that. When I try to move it, it just goes all over the place. Whoa. It's like a video game. I'm going to win. I was off there. I win! All right. I was slow. Thank you. Oh, gosh. Okay. All right, just draw the graph. We'll try not to move it around at all. So I just picked this. I made this up. So on the test, I'll give you 4 points, or 5, or 3, or something like that. And this is our function, f of x. It does pass the vertical line test. It is a function. And we have certain xy values. We have a -4, 0, -2, 2, 0, -3, and 3, -1. And this is to tie in all our understanding together about transformations. I asked last hour how helpful some of the stuff we did was, and they said it wasn't helpful at all. So we'll see kind of what your thoughts are later. Some stuff you just got to wrestle through. It doesn't really matter how the book explains it or the teacher explains it. Sometimes it's just tough. But I think you guys will get this. They said that they got this part fine. They didn't understand what the rest of it had to do with it. So here we go. We want to graph, if this is f of x, we want to graph 2 f of x. 2 times f of x. You tell me, is the 2 on the outside or the inside of the function? Outside, so is that going to affect the vertical or the horizontal? Vertical. It doesn't affect the horizontal at all, does it? As a matter of fact, I could take a function and I could stretch it vertically. Does that change the x coordinates at all? No, it only changes the y coordinates. So here's what I'm going to do. I'm just going to make a table with my... Okay. I'm going to make an xy table, and the x values are going to stay the same. So up there I had -4, -2, 0, and 3. Those will stay the same. What do you think will happen to the y values? Yeah, we're going to multiply them by 2. The output gets magnified by a factor of 2. So 0 times 2 is 0. 2 times 2 is 4. -3 times 2 is -6. And -1 times 2 is -2. So that's our points. And I'm going to plot those. So, good question. Our x values, if you notice, are the same as exactly what we had. The only way that you know what those are is because I gave them to you. So that's what we just start with. And because there's nothing that happens on the inside... I can't. Okay. Because there's nothing that happens on the inside of the function, the x values don't change. Now here the x values will change. Okay, so we'll do something different there. As you graph this, can you look at the graph and tell that from the original it's stretched? Because that's what you should look for. Okay. All right, let's look at the next one. The next one's the most complicated one for people. Is the 0.5 on the inside or the outside? It's on the inside. If it's on the inside, does that affect horizontal or vertical? Horizontal. So is it going to affect the x values or the y values? X values. It's going to affect the x values. Now, We got to think about this, people. This is the part you really got to follow today. The rest will come pretty clearly, but this part you really got to think about. The 2 stretched it by a factor of 2, right? What if there was a 1/2? That would have compressed it. Yeah, would have divided all the values by 2, or would have compressed it to 1/2 of its size. It's opposite on the inside. So if I would have a 2 on the inside, instead of stretching by a factor of 2, it would compress it to 1/2. So if you have a 1/2 on the inside, what's that going to do? Multiply by 2. Horizontal, and I would scroll up so you could write this where I wrote it before, but I'm afraid I'll lose everything as this page is having problems. I don't know why. Horizontal factor is 1 over b. So I'm not going to call it a stretch. I'm not going to call it a shrink. We're just going to think about it, okay, and understand it. If I had a 2 here, the factor would be 1 over 2. If it's 1/2 the original size, is that a stretch or a shrink? That's a shrink. So let's put 0.5 in there. What's 1 divided by 0.5? Positive 2. So is that a stretch or a shrink? Stretch. And because it's on the inside, it's horizontal. So here's what we're going to do. We're going to take our x values and we're going to double them. That's what this 0.5 does. Doubles our x values. So instead of -4, we have -8. Instead of -2, we have -4. Instead of 0, we have 0. Instead of 3, we have 6. So the x values get doubled. Let me try this. If this works for you, great. If it doesn't, then we'll try later, okay? Forget about the +1 right now, okay? All right. You know, if I plug in -4, I get out a value of 0, right? We said that from the beginning. -4 is 0. Okay. So if I plug in -8, what's 0.5 times -8? And what's f of -4? What did we say from our beginning? 0. See? If you would plug in, say you took it by half, you plugged in -2, then you would be evaluating f of -1. You don't even know what f of -1 is. But if we plug in -8, we get -4, and we know what f of -4 is. It is 0. Okay? So instead of reducing the size of the x, you have to increase it. Whereas if you had a 2, you would have to decrease it. It's opposite of what you think. If it's less than 1, it's a stretch. Yes. 1 over b, opposite of what we think. Okay, so let's look at what happens vertically, okay? The 1, is that on the outside or the inside? Outside. And does +1, that shifts it up 1 or down 1? Up 1. So what do you think we're going to do with the y values? Just add 1. You guys do not do this. Some people will take this and then they'll transform it here, then they'll transform this one over here. I always start with the beginning one, okay? So what's the y value from the beginning? 0. So it becomes 1. 3, -2, -1. Oh, 0? I'm sorry. I can't remember the point. So I'm going to plot these. -8, +1. -4, +3. 0, -2. And 6, 0. Does that look like it was stretched horizontally? Yep, and that's what we should see. Very good. All right, let's look at this one. The x minus 1, is that on the inside or the outside? Inside, so is that going to affect horizontal or vertical? Horizontal, is that going to be a shift to the left or the right? Right, how many units? 1. So what do we do with all the x values? we add 1. So instead of -4, -3. Instead of -2, -1. Instead of 0, 1. And instead of 3, 4. So Chris D, when you look at this, you look at it, and although it says -1, you think we're going 1 to the right, right? It's opposite of what you thought, right? It's the same way when we talk about multiplying. It's opposite. It's that reciprocal idea. Okay? So if it's on the inside, it's always opposite of what you're thinking. Okay? Question. Yes. Is the negative on the outside or the inside? Outside. So is it going to affect vertical or horizontal? Vertical. So does that affect x values or y values? Y. So we won't change anything with the x values because of the negative or the -3. Now here's the deal. What do you do first? Do you apply the negative or do you apply the -3? We apply the negative because we apply the transformations in the order of operations that they occur. So if you were going to plug in a value, the first thing you would do is subtract 1. That's why we change the x values. Then you would make it negative. Then you would subtract 3. So let's apply this negative. What does the negative out front do to it? Flips it vertically, right? So that's going to change the y values. So if you had +3, that would become a -3. Okay? After you make it opposite of what it was, you're then going to subtract 3. So our first y coordinate is 0. We make it negative, it becomes 0. Subtract 3 and we get -3. Our second y coordinate is 2. Make it negative to get -2. Subtract 3 to get -5. Our third y coordinate is 3. Make it negative. I'm sorry. Third y coordinate was -3. Make it negative to make +3 and subtract 3 to get 0. The last coordinate was -1. Make it opposite to make it +1 and subtract 3 to get -2. So that's what we do. You change the x for the insides, the y for the outsides, and away we go. -3, -3, -1, -5, 1, 0, 4, -2. Does that look like something that's been vertically flipped? It sure does, because here you can see you have a peak and then a valley. Here you have a valley and then a peak, so you can tell it's been flipped. It's also been shifted down 3 units. It's also been shifted to the right 1. And now we move to our last one. I start, in the order of operation that I'll evaluate something, so I look at the inside. What is the negative going to do on the inside? Flip it over the y-axis. So is that going to, it's going to be a horizontal reflection because of this negative. Is that going to affect the x values or the y values? The x values. So instead of starting with a -4, I start with a +4. -2 becomes +2. 0 becomes 0. And +3 becomes -3. So we switched all the x values. Now, do I do ×2 or +2 first? ×2 first. Will these affect the outside or the inside? Outside, so the vertical part, so the y values. So we're going to take the y values, we'll multiply them by 2, and then add 2. So this was 0. 0 times 2 is 0, plus 2 is 2. The y value here was 2. 2 times 2 is 4, plus 2 is 6. The y value for 0 is -3. -3 times 2 is -6, plus 2 is -4. And then the last one, the y value is -1. Times 2 is -2, plus 2 is 0. We sketch the graph. Over 4 up 2. Over 2 up 6. 0, -4. -3, 0. Does that look like something that's been flipped around the y-axis? It sure does. So you can see how we generate the coordinates. I think that that was the hardest part for people on the test last year. I thought that was the thing that when they went in the test, they're like, we still don't understand that, Mr. Gentz. And so then I showed them that thing, and then they said that they got it. But when I asked last hour, they said, this just confuses me altogether. I do understand that, and so we can just completely get rid of it and exit it from our brains, okay? But, as I said before, second semester, we have to be comfortable with graphing things of this nature. And so A, B, C, and D just represent values. And so although you may not like all the letters, this is where more of your mathematics will go. So that form will be important for the future. So I get if this doesn't connect with you. Last year it did. Probably the order in which I taught it made a little bit of a difference. But that is, believe it or not, that's what's in my brain when I do the problem. So that's what I think of all the time. So, all right, let's flip it over. We're going to do just a couple problems on the back side here, even and odd functions. Then you're going to have time to work. We'll do the last example, example 5, on Thursday, right at the beginning of class, because I want to tie back in your learning from when I've been gone. So, again, tomorrow I'm gone. You can check the answer key and do all sorts of stuff tomorrow. You'll have time to work. So, all right. New definitions. We want to talk about even and odd functions. This is really a piece of cake. Odd functions, all powers are odd. Even functions, all powers are even. I'll give you an example. Yes. Yes. Oh. What power is x being raised to? First power. And we only have odd powers in this function. So it is an odd function. Here, x squared is even. So therefore it is an even function. Let me show you what that means graphically. Odd functions are symmetrical about the origin. Even functions are symmetrical about y-axis. What does that mean? If I draw a basic graph right here, what does the graph of 3x look like? What does it look like? Line through the origin with a slope of 3. Line through the origin with a slope of 3, exactly. Now, look at this, guys. If I took this line and spun it around the origin, it would give you that same exact shape. That's what makes it odd. It is symmetrical about the origin. If you look at this one, the graph of x squared, it's a parabola. If you look at that one, I could twist and spin it around the y-axis, and it would be the same shape. That makes it symmetrical about the y-axis. Now, you can tell by looking at the power. You can tell by looking at the graph, but this is college algebra. We also want to verify it algebraically, and so there is a test. F of negative x, so we plug in a negative x value, and the output ends up the same as the original function, except it differs by a factor of -1. For even functions, we plug in negative x, and we get the original function. So let's try it. Let's try evaluating f of negative x. If I plug in a negative x to this function right up here, I get 3 times negative x. What is 3 times negative x? Negative 3x. Is negative 3x the same as what I started with? No. Does it differ exactly by a factor of negative 1? Yes. So therefore, it is odd. Let's look at the graph of x squared. If we plug in a negative, you get f of negative x is equal to the quantity negative x squared. What is negative x quantity squared? Positive x squared. Is that the same as what we started with? Yes. So therefore, it is even. Now, you don't have to write down the description every time. You don't have to write down the graph. All we're going to do is just do the algebraic test. Okay? Except I want to change one problem. Don't do that. Just so we end up with an example of each, I want this to be f of x is equal to x to the 4th minus x squared plus x. Okay. Let's look at the first function. Are all the powers even? Are all the powers odd? Or do you have both? They're all odd. I have x to the 3rd and I have 4x to the 1. So all the powers are odd, so we should come up with an odd function. Okay? The way we do the test is we plug in negative x. And when you plug in a negative x, we have negative x, that quantity, to the 3rd power, minus 4 times negative x. Let's simplify that and see what we come up with. What is negative x, that quantity, to the 3rd power? You're going to get a negative, very good, and you do have an x to the 3rd. How about minus 4 times negative x? Plus 4x. Is that the same as what you started with? No. But if you factor out a negative, you get positive x to the 3rd minus 4x. Is that the same as what we started with? Yes, it only differs by a factor of negative 1, so therefore it is odd. So the direction state to tell whether it's odd, even, or neither. We could look at the powers right away. We verified it algebraically. We are done. We know that this is now symmetrical about the origin. F of x equals negative x quantity squared plus 10. Are all the powers odd, even, or both? What power is attached to the 10? 10x to the 0 power. What is anything to the 0 power? 1. And 10 times 1 is? So we don't write the x to the 0, but there is an x to the 0 attached. So you're right. This is an even function. Let's plug it in. We plug in a negative x. So I have negative quantity, negative x squared plus 10. What do you get if you have negative x squared? Yes, why is it not positive? Yeah, you square the negative x to get a positive, and then you apply the negative to make it negative. Because you have nowhere to plug the negative x in on the 10, do you? If we plug in the negative x to the x to the 0, the negative x to the 0 is just 1. So there's nowhere we can plug in the x. Yes? Okay. So, very good. If you do negative x squared and make it negative, you get negative x squared plus 10. Is that the same as what you started with? Yes. So therefore it is even. Hey, look at the last one. Are all the powers even? No. Are all the powers odd? No, they're both. So therefore, this will be neither even nor odd. Let's verify it algebraically. F of negative x. Negative x, quantity to the fourth. Negative x squared plus negative x. What is negative x to the fourth? X to the fourth. Minus negative x squared? Minus x squared. I've got a minus x on the end. Is that the same as what you started with? No. Factor out a negative 1. You get negative x to the fourth plus x squared plus x. Is that the same as what you started with? No. So it's not odd. It's not even. It is neither. It does not have symmetry about the origin or the y-axis. We can't say anything intelligent about it right now. That's it. Even and odd. Piece of cake, right? Upside down. Are you guys going to miss me tomorrow? Or are you going to say, I need a break from Mr. Gantz? Which one will it be? Some of you will say, I hope he never comes back. Yes, I do. I will tell you as soon as I write down the assignment. It's up on the board. Numbers 1 through 5, 11, 12, 25 through 33. You had time to work yesterday. You have time to work now. You have time to work tomorrow. You have time to work Thursday. Thursday you should ask me questions. And you should be good to go. The answer key is posted up there for everything. You have 5 assignments along with 2 worksheets. The answer key of the worksheets are posted as well. They're right up here. They got these little clippy doohickey things that Miss Nelson uses because she's super organized. My goal is to be like her. So there you go. This is calculus over here. They'll have stuff for when I'm gone tomorrow as well. Good luck.